This is the first part of problem 1363. We're supposed to consider a solution formed by adding 10 grams of glucose to 1 liter of water, and we're asked to calculate the vapor pressure of this solution at 20 degrees Celsius. We're given the vapor pressure of pure water at this temperature, which is 17.5 torr, which is the same thing as 17.5 millimeters of mercury, just in case you're unfamiliar with those pressure units. So we've got glucose, C6H12O6, and the molar mass of glucose, if you consult your periodic table or your online reference, it's going to be equal to 180 grams per mole. So the first step we want to do here is to calculate moles. So I have 10 grams of this substance, and I'm going to convert it to moles by dividing by the molar mass. Okay, so my grams will cancel there, and I'm left with 0.0555 moles. Okay, I'll leave ample digits here and round at the end. Now, the other information we have here is that we have 1 liter of water, okay? And we need to calculate kilograms of the solvent. Now, 1 liter is the same as 1,000 milliliters. Okay. And we know that the density of water is 1. 1 gram of water is going to occupy a volume of 1 milliliter. Okay? So you need to remember that. That's the density of water. So the milliliters will cancel here, and so that's 1,000 grams, which is the same thing as 1 kilogram. Okay? So 1 liter of water weighs 1 kilogram. So let's go with the 1,000 grams here. Next, what I want to do is calculate the moles of water. So I have 1,000 grams of water, and the molar mass of water is about 18. Okay, and that's 55.5 moles. Okay. Now, next what I want to do is calculate the total moles. Okay, and the total moles is going to be equal to the moles of glucose plus the moles of water. So there's a lot of 5s in this value here. Okay. Next, what I want to do is calculate the mole fraction of water. That's going to be equal to the moles of water divided by the total moles. So the moles of water we said was, down here. That's 55.5. And total is 55.4 of those moles. Okay? And so I get a value of 0.9990. Now what we want to do is apply this last part here, which is Raoult's law. Raoult's law states that the pressure of your solution is going to be equal to the the mole fraction times the pressure of the pure water. So the mole fraction is 0.9990, and the pressure is, excuse me, 17.5 torr. That comes again from the word problem up here, so we don't use that information until the very end. And what I get on my calculator after you round it is basically the 17.5 torr. Okay, I'm choosing to round it to 3 sig figs here. Now, this solution is sufficiently dilute to not significantly affect the vapor pressure, and that's why the answer is the same. We wouldn't know that until we go through this calculation.